Hi, I'd like to talk about one other aspect of linked list accessors, which is that sometimes we don't want to point to the current element. We want to point to a previous element. And I want to show you these two different coding styles. So to do this, we'll revisit a problem from the first homework, which was counting the number of unique elements in a sorted list. All right, so here's a simple playground for that. I've got my linked list set up here. Then I've got my numUnique stub function. And I've got a test here, which is going to test, say, the number of unique elements. So if you think about how to do this, remember that we need to keep track of not only the current element that we're looking at as we're going through a list, but we also need to know the previous element. Now, of course, in an array, we have random access, so we can access any element easily. That's not true in a linked list. So there's a couple of different ways to code this. So let me look at them. The first one looks at the current element and keeps a pointer to it. And then we'll look at one that keeps a pointer to the previous, okay? So keeping track of the current element, when I'm at the third element of this list, looking at this 21, I need to know that I had previously seen the value 21 as the previous element. So the way I can do this is by having three different loop variables. One is to, of course, accumulate the result. I'm going to count the number of unique elements. Then I have my pointer to the current element. So that's pointing here to this element 21, the second 21. And then I'm also going to keep track of the previous value, which would be the previous value that I saw on the list. So now as I go through the list, of course, I'm updating that previous value accordingly. And when I get to 31, I'll see that the previous value was 21, and I'll go ahead and do this stuff, which is to increment the result and to update the previous value. Okay, so this is great, and if you run through it, you can sort of see how the code executes. And let's just look at that. Here I have kicked off the code, and we can see that we're starting numUnique pointing to this list. And on line 12, we're not going to take the condition. Instead, we go to 13. And then on line 14, we allocate the result. Then we allocate the current pointer. So no, current is not pointing to the first element, but to the second element of the list. So for numUnique, we have a special case. For the empty list, then we assume that we have at least one element. And now what we're going to do is point to the current and later. Okay, so we're pointing to the second element and later. And so current here is starting off at the second element of the list, not the first. And what I'm do here is compare backwards. So I want to compare this to the previous element. But note that as current is moving, I don't have any direct access to that. So what I'm going to do is save that in a separate variable called preval. So preval will be initialized to the first value in the list, which is 11. And now what I can do is go around my loop. So what I'll do is here, each time I look, I see the current value, it's 21, and I compare them. If they're different, then I'm going to increment the result, update the previous value, and then move the current pointer on to the next element. Okay, and then we do that again. In this case, there's no difference, so we don't increment the result. We keep going like this, and we're going to keep going like this until we get to the end of the list, where in the last element, of course, you can see that in this case, the current value and the previous value are different. Therefore, we'll increment the result. And now we're going to fall out of our loop. And so note here in this case that current.next is null. Okay, so when I update current on line 23, what's going to happen is, note I'm currently on line 21. So what's going to happen when I update the current pointer is that the current pointer is going to change to be null. Okay, so that's what's happened, and that's what's going to terminate my loop. When current hits null, I leave the loop, and then I'm going to return the result. All right, so that's the outcome of this particular coding. All right, so what you can see here is I've got this current pointer, and I've got a current value. I've got the current pointer and the previous value. That's what I'm holding here. But another way of possibly coding this is to have just one pointer, which is pointing to the previous node in the list. And from the previous node, note that you can get to the current node. So there's an asymmetry here. From the current node, you can't go backwards to the previous node, but from the previous node, you can go forward to the current node. And this is a trick we can exploit in order to do the code. So let's look at that solution. So when I'm solving the num-unique problem, I want to start off looking at the second node of the list. Okay, so my previous node will be the first node of the list. So that's what I'll set previous to. And then what I'm going to loop on here is while previous next is not null. So while there is a current node, that means previous next is not null. If previous next is null, that means there's no current node. The current node's gone, right? We're past the end. All right, so what I'm looping here is on prev next not equal null. And if prev next is not equal to null, then I can actually look at both the previous item and the previous next item, that's the current item, and compare them, okay? And so the coding here is just a little bit different. Let's walk through how it works. So in this case, I'm going to kick this off where, again, my result is 1. So we have a special case if it's empty. Otherwise, I assume there's at least 1. And now my previous pointer is pointing to the first node. Okay, so previous is pointing to first. That means my next, my current node, rather, is going to be the node with value 21 there, the first of them. So what I do is I look to see if that's null. It's not. And so we go into the loop. So I can see that my previous value is 11, my current value is 21. I compare them. And of course, in this case, I could increment the result. And now I am going to update previous. So my previous pointer advances by 1. And what I'm looking at is previous next null. And of course, previous next is not yet null. And so we're going to continue in this fashion for a while until we get to here. And when we get to this node, what we'll notice at this point, previous next is not yet null, but it's going to get to be null really quick. There we go. When we get to this node here, you'll see that previous next is actually null. Right? So when previous next is null, we'll terminate the loop. So note that previous itself never goes to null. Because if previous became null, then what is current? It's past null. That makes no sense. All right. Okay, so these are two different ways of coding up the list. And it's interesting to compare the two solutions. So here they are side by side. This is the version using current, and here is the version using previous. And it's just very useful to keep in mind which of these solutions you are using. It's common for students to confuse them. So half their code is assuming that their pointer is pointing to a current node, half their code is assuming that it's pointing to a previous node, and things get confused. So if you're clear in your mind which solution you're using, everything will be hunky-dory for you. And you can see the main differences here is that when I'm going on current, I'm setting current here to be for next. So I'm starting later in the list, and I'm terminating when current is null. Whereas in this other solution here, I'm setting previous to be first, and I terminate when prev next is null. All right, that's a brief introduction of this idea that sometimes when you're going into a list, you don't want to actually hold the current pointer, but you want to stay back one. So it's like a previous pointer, and because from the previous, you can always see forward, but from the current thing, you can't see back.